block cipher modes are how it goes through and encrypts. And just for example, the first set there, if the counter is reused, then you've just blown up your encryption. The ones below, the initialization vectors, if you use the same one again with those block ciphers, you've just screwed up your encryption. You've made it so that it can be broken. And then the bottom is interesting, ECB mode, which was commonly used. It kind of gives you an idea there. I have the URL where I got it from. It's on the left there, you'll see the penguin, right, Tux, and he's unencrypted. The one in the middle is using ECB mode to encrypt. So while the actual little pixels themselves are encrypted, there's a macro image that still stands that you can obviously, you can see it, you can still see the penguin. So, and the one on the right is in CBC mode, that's the chained mode, and that's the one you should be using if you're using a low-level API. So when you send, this is something I didn't know, when you send data to the client, it comes back round trip. You know, what I've always done is just encrypted it using Blowfish. I send it to the client, it comes back, and then I decrypt it. It's just a way of protecting the ID so that they can't fiddle with them. But what I did know is some encryption algorithms, you're able to change the encrypted value and still make it a valid decryptable thing, such that now the value will be different. And you don't have, as the server, you don't have a way of telling when you've sent something that's come back changed and when you've sent something that comes back and it hasn't been changed. There's no way to verify the integrity of it. So what we should be doing, or at least me, is using, Lasso has encrypt HMAC, and that's what you want to use, because HMAC is like a hash, only it uses a secret password. And then the custom hash constructions, this one's interesting. I don't typically send hashes to the client. However, if you do, then it's possible, and in the way you actually concatenate the key with the password with the data, if you actually just concatenate them together, if you're returning that hash to the user, they can choose the data such that they can take away one character at a time, and eventually what they can do is discover what the secret password is using that method. So it's just a way where encryption, can bite you if you don't really understand all the, everything that's involved with how you're using it. So, and just to kind of give you an idea of how real-world big companies make mistakes, I have a couple examples. Wall Street Journal actually had a few flaws with their authentication system, and one of them was that hash where they concatenated the key with the data, and then using that technique, they were able to determine, the attacker was able to determine that the secret key was the word March 20. So, not so secret anymore. WordPress had a vulnerability where the integrity of the cookie could be subverted. Basically, you could change the value of the WordPress cookie and still have it be a valid cookie according to WordPress. And then Amazon.com, their original web services version 1 had a vulnerability where they didn't have proper structure for their data, and because they lacked that, attackers were able to just concatenate a whole bunch of stuff that when it first went in, it passed validation, but then it exposed their services to a particular attack. So I just what I want to bring home is that encryption, no matter how much you think you know it, even some really big sites with, presumably some bright minds are getting it wrong too. And there's dozens and dozens of examples. I just actually read a few days ago, there's a vulnerability with one of the APIs, I think Facebook, where they're using an MD5 hash, and there's this particular attack that you can use on it that actually works. And so what it does is it allows the attacker to pretend to be a particular plugin for the site, so it'll appear to be the plugin for one of their a game or something, and then you have access then to all the private data that that plugin would normally have on that application for Facebook. So it goes wrong lots and lots. All right, so that's sort of that kind of ends the doom and gloom part of it. Now we'll talk about how, types of encryption and how they work, and we'll get into some examples for Lasso. So any questions so far? So there's basically three types of encryption. There's symmetric, there's asymmetric, and there's hash. I'm also going to talk about a subset of hash, which is the MAC, the message authentication code. Symmetric's pretty easy to understand. It's in Lasso we use Blowfish, but you can also in Lasso use DS or triple DS. It's where you have a secret password or a secret key, and you use it to encrypt it, and then you also use it to decrypt it. So the person who has the password is the only person who can then unencrypt the message. So, and here's an example in Lasso. As you can see, I'm using the Cas5 CBC cipher. In my opinion, that's probably the more secure out of all the choices that were available on my machine. You can see the choices on yours by using cipher_list for the tag, and it'll tell you what's available. So this example, you can see what it does is the top one will encrypt it, and I've encode hexed it so that the output is actually something that looks readable. Otherwise, you get some binary data, and it wasn't so printable. But the bulk of it there is you encrypt the word data with the cipher Cas5, and my password there is the super password. And then down below, you decrypt it. So you take your value, and in my case, I have to decode the hex, and out pops the word data. Pretty easy, right? I think, has everyone used encryption in that way, I think? Yeah. Okay. All right.
Hey, Bill?
Yeah?
You might be getting to this, but is there a list of the schemes that are common across all the platforms that Lasso uses?
That's my knowledge. I think on the list it came up one time, I think there was a couple of platforms that posted what was returned, and I think the bulk of them are actually shared, because I think underneath Lasso uses OpenSSL for those. So yeah, but I don't know of one in particular that's safe. And then someone else had posted actually that even though it only returned a certain subset, that actually there was a few more that they could specify that worked. So even if the list doesn't show it, doesn't necessarily mean it won't work. But like I said, my goal for Lasso would be to move away from using that unless you specifically need it for interoperability with an application that sits outside of your control, PHP or something. Otherwise, I think we need to move towards this using the higher APIs to manage these things, and that's what I plan on working on in the next few months.